Algebra 2, Lesson 59, Experimental Data, Simultaneous Equations with Fractions and Decimals, and then Rectangular Form to Polar Form. So for two of these problems, we're going to be using our calculators. So on Experimental Data and Rectangular Form to Polar Form. Again, this is like a science-like problem, which is why we'll be using our calculators, because we want as exact an answer as possible. And then Rectangular Form to Polar Form, we'll be using trigonometric identities. So again, we'll be needing our calculators. Starting with experimental data, I'll try to run through these as fast as I possibly can. They give us this graph on the right and this word problem on the left. They tell us the data points shown come from an experiment that involves nitrogen and fluorine. Write the equation that gives nitrogen as a function of fluorine, or N equals the slope of F plus B. So if you replace N and F with Y and X, that would be Y equals MX plus B. They're just showing you how you can use your slope and line equations in application. When you have graphs, you think of the nitrogen as the y and the fluorine as the x. So essentially all we have to do is just find the slope of this line that they've given us. Now the data points plotted won't all land on the line, but the line is kind of like the average of what the data shows, or the trend and what they show the data is giving. So we want to find the equation of this trend so we can predict what would happen in the future. So we'll just pick 2 points on the graph here. Let me see. And we see that we don't really have any great points that stack up perfectly on the line. So we'll go ahead and we'll use this data point of 232 to find our slope. So that would be a rise of 200 and then a run of 32. So that would be our first point. We'll use 232. I'm going to go ahead and write that on our work page. And then the second point, we're just going to have to pick one that's pretty close. So we'll trace our line. That's nowhere near. That's kind of close, but I don't know. It's still kind of far away. Not quite there yet still. This one's pretty close, and it's got a good distance. So when you determine your points, you don't want to pick something too close together, because then you increase your margin of error. So we'll go ahead and we'll pick this one way up here. And we'll just use 450. So if we read the graph, that'd be 450 for our y point. And then our x point would be 35. And I went ahead and I wrote those points on our work paper. So what we're doing with these 2 points is we're going to find the slope, the m. So if you remember, slope would be y1 minus y2 over x1 minus x2. So we got 200 minus 450 over 32 minus 35. 400 or 200 minus 450 would give me negative 250. 32 minus 35 would give me negative 3. The two negatives cancel, giving me a positive slope, which is what we see reflected in the graph. So that's good. We know we're on the right track. So our slope would be 250 over 3. Now instead of using this in fraction form, we're going to use our calculators to put our slope in terms of decimals. So we take 250, divide it by 3. We get 88.3333 with a line over it. So our slope, or m, is going to equal 83.3 with a line. Now we have to find our b. The way we do that is we take our slope and we plug it into the equation, and we'll use 2 points. Now the points I'm going to use are this 32/200 point, because that's the most accurate point I have. I actually guessed on the other one. So the equation, if you remember, is nitrogen equals slope times fluorine plus b. So I'll be plugging in the nitrogen value, which would be the y of 200. I'll be plugging in the slope of 83.3 with a line over it, times the fluorine value of 32. And then I'm going to solve for b. So I'll go ahead and I'll take my calculator, and since it's already at 83.3, I'll just take that number and I'll multiply it by the fluorine value of 32. That gives me 2,666.66667. I'll just round that to 2,666.67 plus b. Alright, so to solve for b, all we have to do is subtract this number from both sides. And then that would give us b. So b is going to equal 200 minus that. So I'll go ahead and we'll use our calculators for this, so that way we maintain some accuracy in our decimals. 200 minus 2,660 0.67. And I get minus 2,460.67. So my final equation is going to be written by plugging this b value and this m value into this n equals m times f plus b. So it's going to be n equals 83.3 f minus 2,460.67, and that's going to be my answer. Now moving on to B. Sorry, this is going to be probably the longest video of the year because this is a lot of heavy stuff. So B, we have two equations. They're both written in different forms. All we have to do is just rewrite each equation in whole numbers. There's two ways to do this one. I'm going to go ahead and use the greatest common factor method. The greatest common factor method would be 21, so I'll multiply everything in the equation by 21. So what that does is when I multiply this, that would cancel and that would become 7, so then I get 7x here. That cancels, and then 3 times 2 gives me 6, so 7x plus 6y. And then that's going to cancel again. 3 times negative 3 would give me negative 9. Now for the bottom equation, I can rewrite that by multiplying everything by 100. So I'm just going to move all the decimal places 2 spaces. So that gives me 1x minus 60y equals 303. And then I'm done with these two crazy looking equations, and I've got some simpler looking equations. From here you can go ahead and solve using substitution or elimination, but the key thing is rewriting each equation in terms of whole numbers. I'm not going to go over substitution and elimination because you guys should be very good at that by now. The last one, convert negative 3r to negative 5. Convert negative 3r minus 5u to polar form. So we have to draw a graph, and we're going to plot this angle. So negative 3r is going to be left, so we go left 1, 2, 3, and then negative 5u is going to be dropping 5, so we go down 1, 2, 3, 4, 5. And this is going to be our vector, or our number that we're dealing with. Now we have to pick a triangle. I'm going to go ahead and pick this one because that length is going to be 3 and this length is going to be 5. We know that from the graph. So we can use Pythagorean theorem to find the hypotenuse. So if we have 5 squared plus 3 squared, that's going to equal c squared. 25 plus 9 gives me 34. So c squared equals 34, so c is going to equal the square root of 34. 34 can't be factored. If we divide it by 2, we just get 2 and 17, which are both prime numbers. So c is going to equal the square root of 34. So in polar form, we already have the distance of our angle. So our answer is going to be root 34 times some angle. We have to figure out this angle. To figure out that angle, we have to use our calculator and our trigonometric identities. Now for the trigonometric identities, I'm going to go ahead and use the opposite and the adjacent side of this angle because I know those numbers for sure. Square root of 34 is an irrational number. It's a little bit harder to work with. So that we're going to use the tangent identity, and that is the tangent of theta equals the opposite of 5 divided by the adjacent of 3. So to solve this, theta, we can divide each side by tangent because we gotta get theta by itself. And when we divide this by tangent, that's the same as writing tangent negative 1. So what we really have to do here is tangent negative 1 of 5 over 3. And that's going to equal our angle. So we go to our calculator. We're going to type second or shift tangent. And then we'll put 5 divided by 3, end the parenthesis, hit enter. And our angle is 59.04, rounds up to 0.4. So theta, our angle, equals 59.04. Now I'm not just going to write that up there because that's only the angle of this triangle. The whole angle of the vector we're dealing with starts from origin and adds an extra 90, 180 degrees to that. So that plus 180 gives me 239.04 degrees. So that's angle 239.04 degrees. Now, the other question is, actually I gotta check and see if you guys do negative angles. 1 second. Okay, great. You don't have to worry about negative angles like the trigonometry class will have to, but that's your final answer right there. Alright, so use Pythagorean theorem to find the hypotenuse, and then use your trigonometric identities to find the angle, and don't forget to add any pre-existing angles from origin.